Section 13.1, we want to work on parabolas next. And problem number 44, if I remember right, is a parabola x equals 2y squared. Now, can anyone notice anything different about the equation here? What's a little bit changed from what you're used to? Yeah, you've got x solved for, and y is the term that's getting squared. So let me make a suggestion here for us. Usually we put in values of x and get values for y. But since you've already got x by itself, how about if we switch that up? How about if we put in values for y and then get values for x? So I'll start out, okay? If we put in a 0, 0 squared is 0 times 2 is 0. So there you go. There's a start. 0, 0 is one of your points. Let's put in some other ones. If you put in a 1, 1 squared times 2, 2. What's 1 squared times, or excuse me, what's 2 squared times 2? 8. And then we got to do the same thing with the negatives. And here you got to be at least a little bit careful. So for instance, if we were to put in y equal negative 1, you get x is 2 times negative 1 squared. When I put those things in, when I put in negative values in particular, always do it with parentheses. So when you square this, you get a positive 1 times 2 is 2 again. What happens when we plug in negative 2? Negative 2 squared is 4 times 2 is 8. So why don't you graph all those points, see what you're going to come up with. Is anyone seeing anything unusual about these points? Or what's it saying about our parabola? Mindy, I think you've got an idea / suggestion. What's going on with this parabola? What's different about it? Yeah, this one faces sideways. When you have a parabola in y squared, it's either going to open to the right or open to the left. It's not going to be opening up and down. Those are reserved for parabolas that have an x squared term, not a y squared term. So, okay. Well, let's move down to a different type of parabola problem, kind of similar to what we just did, but we're going to extend our work some. The things that I want you to be able to find in section 13.1 are exactly the kinds of things we worked on in our previous work with parabolas. I want you to find the vertex, the x-intercepts, the y-intercept, and that's it. I mean, there's an axis of symmetry, but I'm not going to worry about it. Let's look at problem 46-ish, and I think I just changed this from a 1 or 2 to a 3 or something like that. It wasn't a big change. But the first thing that we want to find would be the vertex. Now, to find the vertex, what you should work on is figuring out what makes the squared term equal to 0. So in that sense, it's just like our work with circles. What makes the squared term equal to 0? 2. But 2 for what variable? 2 for y. Let's put in a 2 for y and see what happens. You're going to get x equals 3 times 2 minus 2 squared minus 3. And what I'm hoping is that after this example, you really won't need to go through all this work. If you put in a y equals 2, you get out an x equals negative 3. So there's your vertex, 2, negative 3. But you can kind of figure those things out by looking at these equations. So 2, negative 3, and you know what? That might not even fit on our graph very well. Oh, perfect. You know what? Thank you. Yeah, I do what my students do all the time. I mix up the x's and y's. So negative 3, 2, which is much better because that will fit on our graph. So all is right with the world. The lion and the lamb are best friends, and there will be peace in the Middle East. Cool. Thank you. Let's keep going here. So that's vertex. That's one big point that we need to find. Make sure you write an x and then y. Let's move on to other points. For instance, suppose I want to find the x-intercept. Emma, how do you find the x-intercept for a graph? Plug in 0 for y. Good. So for the x-intercept, we're going to set y equals 0. So it'll be x equals 3 times 0 minus 2 squared minus 3. So 3 times 4 minus 3 gives you 9. So that's another point that we're going to have to graph is 9 and 0. 9 for x, 0 for y. There's lots of good review stuff in this section, and that's going to include finding the y-intercepts. So let's find the y-intercepts. Gil, what am I going to do to find the y-intercepts? Good. Set x equals 0. So I get 0 equals 3 times y minus 2 squared minus 3. Kyle, suggestions on how I might solve this? What can I do to figure out what y equals? What's the path of least resistance? Good. Add 3 to both sides. And what Kyle's heading for is using the square root property. Now what? I added 3 to both sides. It's a good first step. Divide by 3 on both sides, all right? That's going to work out pretty nice. Because it leaves me with the left-hand side of a nice value of 1 equals y minus 2 squared. Kara, how would you solve in this case? Trying to solve for y. Perfect. Yeah, the square root property. So I'll take plus or minus the square root of 1 equals square root of y minus 2 squared. Let's bring that up here. I get plus or minus 1 equals y minus 2. Now what you have to be careful of is that there's really two equations here. There's a positive root and a negative root. There's nothing wrong with working with the plus or minus. Just got to be careful at the end. It's positive 1, or just 1, equals y minus 2, or negative 1 equals y minus 2. If I add 2 to both sides, I get y is 3, or y is negative, actually positive 1. So 1 or 3. Overall, my corresponding points would be 0 and 3, and 0 and 1. Let me circle all the important points that I need here from this, from all this work here. So I'll need these two, this one, and this one. So the vertex would be worth 2 points. Let's graph that first. Negative 3 and 2. That would fit in right here. Then at 9 and 0, well, that's off the charts. So that's starts here, probably about here, really. And I regret that my graph is not big enough. Sorry about that. What else do I need? I need points at 0, 3 and at 1, 0. And then I just need a big, big graph. So something like that. Notice that through the vertex you have a line which I could ask you about. This is the line or the equation y equals 2, and it's your line of symmetry. The parabola is going to be symmetric about this line, and if you notice, our y-intercepts follow that pattern. One's just above, one's just below, a distance of 1 away from the axis of symmetry. So a lot of good review in this. Let me kind of recap a little bit. You start by figuring out what makes the squared term equal to 0. That was y equals 2. When I put in a y equals 2, that term disappears. You get x equal negative 3. So hopefully you can just read off the vertex just by looking at the equation. If you set y equals 0, you can find the x-intercept. So we get 9 and 0. Setting y equals 0, you get the, setting x equals 0, you get the y-intercepts. There's a lot of ways we could solve this. We solved it using the square root property. What else could I do if I didn't want to use the square root property? That'd still be kind of using the square root property because it's something on half power. You could multiply it all out and try and factor it. This one actually would factor. Eventually, it'd be a lot of work. There's one last way that we could tackle this if we wanted to. If we're looking at that going, I just never really liked the square root property. What's the last thing you could do to solve this equation here? Solve that quadratic equation. Quadratic formula. So, again, you'd have to multiply it out. You have to square this first, y minus 2 times y minus 2, then distribute the 3, then subtract the 3, in that order. So, yeah, saw somebody shaking their head. It's like, no, not me. Square root property is definitely the path of least resistance on this one. Any other thoughts on problem 46-ish? Let's try problem number 58. So the equation in 58 is x equals negative 2 times y minus 2 squared. Oh, excuse me. Yeah. Wait. Plus 2. Thank you. Plus 2. Never happened. There we go. All right, I mixed up my 1 and my 2 when I was putting that down here. So minus 1 plus 2. Perfect. So again, we need a set of points here. I want the vertex. I want the x-intercept. I want the y-intercepts. And then you should be able to graph it. Do you want to do this one together, or do you want to do the next one? Or, I mean, one of these you should do by yourself. We can do one more together or not. It's up to you. Want to do that one? All right. The nice thing about that one is you've already got the square completed for that one. can't really graph these very easily on your graphing calculator. The reason is you've got X solved for. Your graphing calculator requires Y solved for. You could solve for Y, but by that time, you might as well just graph it by hand. The graph does pass through the origin. That's okay. I suggest you do it like this. Doing up a table, you have to be a little bit clever because you have to choose the correct set of values. Right, exactly. So one of the points that you're going to get really kind of occurs twice. That's okay. You have an X and a Y-intercept that are the same. Yeah, because it's an X-intercept and a Y-intercept. If you look at the last problem, we had 4 points when we found the X and Y-intercepts and the vertex. This one we only get 3. Something like that. Should have 2 points right now. It would be obvious when you try to graph it if you mix those up. And I'll show that. Let's start with the vertex here. What value makes the squared term equal to 0? 1. Now, you have to be careful that it's 1 for y. Not 1 for x, but 1 for y. Usually, we're just in that mode, and I did that problem. I made that mistake in the last problem. 1 for y makes all that disappear, and we get 2 for x. So there's your vertex. Let's find some intercepts. We'll start by finding, say, the x-intercept. How do you find the x-intercept? Set y to 0. So if I set y to 0 to find the x-intercept, I get, let's see, I can do that here. No, I'll do it up here. X equals negative 2 times 0 minus 1 squared plus 2. Negative 1 squared is 1 times negative 2 is negative 2. Added to 2 gives me 0. So, okay. 0, 0. Passes through the origin. Let's find the y-intercepts. So, if I set x equal to 0, so let's do that. Set x equal to 0. Yeah, setting y to 0 gives you the x-intercept. Setting, no, I set y equals 0, I got the x-intercept. If I set x equal to 0, I'll get the y-intercepts. That's all right. I appreciate you checking me. So 0 equals negative 2 times y minus 1 squared plus 2. What I would do is I'd pick this whole term up and move it to the left-hand side where it becomes positive. At least the coefficient becomes positive. The only reason I did that is it's a quick and easy way to get rid of the negative. You could have just moved this over to the left-hand side and had negative 2. And once you divide to get rid of that coefficient, you'll end up with the same equation I do. Y minus 1 squared is positive 1. So you should get there regardless of how you approach it. If I take the square root on both sides, I'll get y minus 1 equals plus or minus the square root of 1. There's two possibilities here. Either y minus 1 equals 1 or y minus 1 equals negative 1. Both of those are realistic. So one gives you y equals 2. The other one gives you y equals 0, which, oh, bummer. So what's happening is you're getting this point twice, because not only is it an x-intercept, but it's a y-intercept. In our last problem, when we did this kind of work, we got really 4 different points. But that's because my x-intercept and my y-intercepts were different points. Here they're sharing a point, and that's the origin. Yes, sir? If you can see that, or if you start out by finding, say, the y-intercepts and realize, oh, well, gee, the x-intercept is going to be the same thing. No, you don't have to go chasing it. No. No. So that'd be fine. If you could spot that just by looking at these right away, great for you. All I'm going to be looking for is these points. So I've got a point here at 0, 0. I've got a point at 2 and 1. And a point at 0 and 2. You can see that this has to face to the left. It faces to the left because there's a negative in front of your squared term. And it's because it's a y squared term, not an x squared term. Nice. One little thing here. Your points should line up. It's very easy in a problem like this, I did it in the last problem, to accidentally interchange your x and y coordinates. Fortunately, Mindy caught me. But if I interchange my x and y coordinates accidentally, if I had the point, say, 1, 2, well, 1, 2 would be right there. Does it look like you could draw a nice parabola through this point, and that point? No. If your points don't line up, it's telling you something. So pay attention, because I'm going to give you a nice graph. It'll work out fine, but if you accidentally make a mistake with your coordinates, then they're not going to look like they line up too well. These line up pretty nice. Let's finish this off with one last one. Any thoughts on 58? Last but not least, problem 58. We got to complete the square here in order to figure out what the vertex is. So what I'll do is I'm going to move this 8 to the other side. X minus 8 equals y squared plus 6y. And then I'm going to complete the square on that term. Actually, you're going to complete the square. Somebody's going to tell me what I have to add here to make this a perfect square trinomial. Colin, thanks for volunteering. What number am I going to add here to make this term here a perfect square trinomial? This is just what we did a moment ago with our equations for circles. Take half middle coefficient. And then what? Half the middle coefficient, and then, yeah, 9. So half the middle coefficient squared, so we get a 9 here and a 9 here. The right-hand side is y plus 3 squared. 9 plus 8 is x plus 1. Finally, let's get the x by itself again. I'll move that 1 back to the right-hand side and get an equivalent form of the equation. It's y plus 3 quantity squared minus 1. This and this would be identical if you graphed them on, say, Desmos. They'd give you the identical graph. But the second one's a little bit more user-friendly. Rachel, what do we get out of the second one that we can't necessarily get so easily out of the first one? Is there something that I can figure out about this one that I couldn't figure out up here? In terms of the graph? Yeah, the vertex, right? So what's the vertex on this one? Nice. And in order, too. Y is negative 3, and x is negative 1. That's your vertex. Now, as far as the rest of it's concerned, here's one for you, Mitchell. You can choose either one of these in terms of finding your x and y intercepts. We've got two equations that are essentially equivalent. So we've got equation A here and equation B here. So if you wanted to find, for instance, the next easy point to get would be the x-intercept, right? What do we have to do to find the x-intercept? Set y to 0. Where does it look like it's going to be easier to plug in a 0 for y? In the first equation or the second equation? I'd say the first one. Can anyone just tell me if I plug in a y equals 0, what x would equal? 8, right? Because that term and that term disappear real quickly. So that's your x-intercept. I need a y-intercept. Y-intercept. And for that, I'm going to set x equals 0. And again, you've got your choice. Equations A or equations B. So which one would you choose? Where does it look easier to solve? Up here or down here? B would be nice. If I chose B, then I'd use the square root property. But if I chose A, I mean, do I got to break out the quadratic formula for this one? Do I have to complete the square and then use the square root property? You can factor it. This is, again, a good reminder of stuff for your final exam. How does it factor? 2 and 4. So you get y equals -2 and y equals -4. So that stuff about completing a square, the thing we got from it was the vertex, right? We didn't have to use it the rest of the way. But that's why we completed the square, is to find that point. I mean, that's a special point. We can't really graph a parabola without knowing where the vertex is. So 0, 0, -2, and -4. The rest of it is draw your graph. Vertex was at -1 and -3. -1 and -3. That's right here. I have a y-intercept. This give me an x-intercept at 8 and 0. That's up here. My y-intercepts make sense. They're both evenly spaced or symmetrically located above and below my vertex along this horizontal line. Let's see if we can draw a decent graph. I'm not sure, there's probably a good chance that I could ask for this line. What's the equation of this line here? Our axis of symmetry. -3 for what? That would be this way. We want horizontal. Y equals -3. So y equals -3. I haven't drawn the other side of this parabola yet. The reason I haven't is because, it's tough to do this freehand and know exactly where to draw. I'm not going to make you do this, but it can help. This is an axis of symmetry. So if I have a point that's 1, 2, 3 units above here, where else would I have a point? 1, 2, 3 units below. Yeah, so basically what I'm doing is I'm giving myself another point to shoot for, another target to aim at, and it's just going to help me draw a nicer graph. You don't have to do it. I do sometimes give out extra credit for people who take the time to go that extra mile. That's looking pretty good, considering that we did it freehand. The bottom line is what I want from you is that I want these 4 points, the y-intercepts, the vertex, and the x-intercept. So 8, 0, 0, -2, 0, -4, and -1 and -3. Those 4 points, that's what I'll be looking for. And perhaps the axis of symmetry. Please.
At the top, when you're completing the square, I get that you put the 9 on both sides, but then how did you go from that to equals y plus 3 squared?
So this first step right here.
How'd you get there?
Sure, good question. And the answer is that y plus 6, or y squared plus 6y plus 9 factors into y. Well, I need two things that multiply to 9 and add to 6. So it'd be y plus 3 times y plus 3.
Oh, so you're factoring. Okay.
Yeah, and there's a different way you can write that. It's y plus 3 squared. So I just jump from there down to here. This is always going to happen, though, automatically when you complete the square. We're engineering this to happen. So your shortcut is once you figure this out, the number that you take, when you take half of this and you get 3, that's going to be down here. So in a previous problem we had half of -2 was -1, so it factored into like y minus 1 squared. But that number that you get when you take half of this will be part of your factorization. Anything else on completing the square or problem 48, parabolas in general? For homework, try 15 through 47 and 59.